Good afternoon, everyone, and thanks for staying back till 4 5 p.m. on a Saturday evening or an afternoon. So I appreciate that. So I'm going to talk about the Amazon forensic platform and how do we scale our digital forensics. A bit about me. I work as a security engineer in the forensic and malware team, which is part of the Amazon Security Operations Center. Prior to Amazon, I used to work at Cisco, and before that I have roles spanning from network engineer, and somehow I've reached into information security and into forensic and malware. So how we have laid out this agenda is basically just introduction on what this talk is about, and basically 3 eras, or spanning on our tooling and the timeline on how we used to do things in old days, what we are doing now, and what is the future. At Amazon, it's always day one because we are still a big startup. So that's why even now what we are doing is still as a startup, and that's our pretty much story. So what is ASOC and what does it comprise of? So we have basically 3 teams: incident response, forensic and malware, and detection and monitoring. All these 3 teams are spanned across 3 regions, Seattle, Sydney, and Dublin, to cover the global follow the sun model. And we basically take care of all the incident response activities for the Amazon retail website, and our focus is not on AWS side of things, in the sense of AWS services, which power the AWS cloud. Our function is mainly Amazon consumer or retail business. The scope of this talk is basically focused on response side of things, and to be precise, on forensic acquisition and analysis. We will not be talking about the detection and how it makes it to forensic and things like that. Also, one of the response generally is about remediation. How do we remediate things? Again, in this talk, we won't be talking about remediation because that's entirely different story. Having said that, it is our team's goal to have remediation, but this is about scaling, how we acquire things at a scale on Amazonian scale, and how we analyze what we have acquired. And remediation, we are keeping it out of our workflow for now. So why this talk, and what does it take for Amazon to scale, and what is the challenge? We have offices and fulfillment centers which are basically responsible for shipping things in many countries. Across those offices and fulfillment centers, we have thousands and thousands of hosts on corporate network, laptops, desktops, which are Windows, Mac, Linux, and whatnot. And the more challenging thing we have is our Amazon.com website is basically in the AWS cloud. So we have millions of servers basically powering that Amazon.com website and anything around it, especially our other subsidiaries, what we acquire, they are all moving into the cloud. So that's another responsibility for us, to give them capability into acquiring either from a corporate network or from the AWS cloud. So what is day 0? Day 0 is basically long time ago when we used to do everything manually. It was mainly about cold forensic, not really live forensic at that point. And we'll talk about some of the tooling we had and how from doing manual analysis and things like that, we moved into doing automation and things like that. So day 0. So I don't know, many years ago, everything was manual. Someone would basically take a DD image, copy it into an external drive, and upload it to a central location. That would be someone's server, FTP server managed by someone, or in a particular cloud or something like that. So it would take a long time to, first of all get DD, then again have to upload it, and then copy into another analysis machine. So before we actually got to do anything like analysis, it would take about 20-25 hours to get everything in line. Because if our IT team or our forensic team is not in that particular geographic location, people would ship the laptops or the hard drives across the regions and stuff like that. So we would wait for like 4 weeks to just get hands-on to a drive and then start the upload. So this was again very manual, using the tools which were at our arsenal. So if an engineer wanted to use DD, that's fine, go for it. If they had another commercial tool which was freeware or paid, yeah, they would use that. It was not very standardized, and this was many, many years ago. So there were a lot of pains on that. Of course, giving manual and things like that. No standard process, where sometimes we didn't have write blockers or anything like that. So we got together, we as in people who worked before me at Amazon, they got together and came up with developing a particular tool and a process to acquire this in a much more simpler way and in a more unified way. So this is one of the tools which was developed in Python, and what it would do is it will upload directly to an S3 bucket. So it would not store anything locally or into any external drive. It would straight start reading from the disk, which is attached via a write blocker, and upload it straight into S3 bucket. So the entire process was basically, you get a drive or a laptop, you unplug the drive, put it into a write blocker, and you basically run this software with some configuration, upload to S3. Why S3? Because one of the greatest things we found when this feature of multi-part was rolled out into S3 is that you could chunk up your object or a file into certain parts, and you could upload those parts only. So for example, you could chunk up physically, saying that you split a file, or logically. So for example, if you have a drive, if let's say it's 250 gig, so you would first chunk up, let's say 5 GB chunks if you want to do, so maybe 2,000, 3,000 chunks. And you start reading those chunks and straight away upload it to S3. So given this opportunity, what would happen is that if for some reason the upload was failing, we had the opportunity to resume it from where it left off. So if it had uploaded 50 parts and after that it failed, the local machine where it was copying and running Polaroid would have an update saying that we have already uploaded 50 parts and I need to resume from the 51st part onwards. So it was failure protection, as well as we could pause it. For some reason we want to pause and run something different on that particular machine, we could pause that copy and resume it after an hour, and we will begin from the 51st part. So this is basically a massive feature from AWS S3 bucket, and those who are not aware of what are the quirks around this. Basically, the minimum multi-part, like one chunk you can upload, is 5 GB, and I think it goes up to probably 1 terabyte chunk. So how this all works is basically, this is the flow diagram of Polaroid. So when we start reading a disk, we first create a chunk map as such, and every chunk is hashed. And end of the entire disk, it is copied and a hash is calculated. Now the interesting part is that once it is uploaded, everything is uploaded to S3 using multipart, we also attach metadata to S3. This is again a feature of S3 where you can attach metadata, whatever you want, in sort of JSON format onto the object. So what this helps us to do is we attach the hash on the metadata of the entire drive. We attach our incident IDs, ticket numbers, and any other information which is useful, and we store it in S3. Another cool feature of S3 is like it's very, very durable. S3 gives you like 7 nines or something like that for durability. So, and we can store the data. We don't have to worry about expanding the disk after we have uploaded hundreds of drives. So if you had an FTP server or SFTP server or something like that, after a point, either you have to delete it or migrate the disk off, and then again, or add some other drives or RAID or NFS or anything like that. But in S3, we don't have to worry about it. AWS manages that. So the multipart thing, the ability to the manage storage, those all things are really, really good, and that helped Polaroid. So this helped us to, from 25, 30 hours, the time reduced to 10 hours. So basically, we would cut a ticket to our IT support saying that, hey, you need to do this for this particular host, and they would basically attach a write blocker and start this process. And once this is completed, we would get a notification that, hey, this has been completed, and we can go further with our analysis. But as everything, every tooling, every automation, there are some pains. This solved the first problem of not being that much manual than the previous method, but it was still semi-manual, where we cut a ticket, the IT support gets it, depending, because this was a big dependency on IT support. So they have to wait for their resources to be free, also make sure that the right blockers and the right adapters are available to them. And it was still like 10 hours is quite a lot for us. We wanted to reduce it further. Also, like the write blockers and SSD adapters started becoming expensive. For example, earlier when we had simpler SSDs or simpler drives, it was like IDE, SATA, this was all fine. But then came the SSDs which are NVMe PCIe. To get a write blocker for that used to be like $506 a piece. So that started becoming more expensive for us as well. And the other problem was that some of the vendors, laptop vendors like Apple and things like that, the newer systems, the newer laptops came out where you could not pull the drive out. So that was again an issue for us. If you can't pull the drive out, how do you copy it? And you have to do some other things. So we spoke about the acquisition part for day zero, the cold forensic things. The other thing is like, how did we analyze those acquired disks? Because at any point we used to have 15, 20 disks a month coming in, disk images coming in to copy, and with a skeleton stuff, it's very difficult to analyze all that manually. Or even if you have all those awesome softwares, commercial softwares, it's still time consuming. So we needed something wherein we could at least triage it quickly, or once it is copied, once we have acquired the image, what if there was a workflow which would do the basic things like do the registry, browsing, and timeline and prefetch, so that, and if you're looking at a malware or even like some other e-discovery kind of things, you have a timeline or you have basic artifacts which allow you to triage these things. For example, like for most of the NTFS related or Windows related analysis, you will always start with the timeline first or browsing history or registry. Most of the malware can be triaged from these 3 or 4 different artifacts. You don't have to do everything. So this was the goal, that Accidental Tourist, this is the software written many years ago, and it was basically a bunch of different bash scripts and Perl script put together, stitched together, and basically it worked for us. So now we like to do automation. We like to make things much more simpler. So how does Polaroid acquired images and Accidental Tourist work as automation? So if you see on the diagram, you have an Amazon office which has a drive, and they are using Polaroid to upload into S3. So for example, when so what would happen is that we would give the IT support guys which exactly bucket we want to upload into. So for example, we keep data separate from EU, US, and a couple of other regions where the data privacy laws are strict. So always when we copy the data from EU, it never leaves EU. It stays in EU. Similarly, when we do any analysis, the data does not leave EU. So from the Amazon office, it will go to the bucket in whichever region we have configured it to go to. And as soon as we have this particular upload and SNS notification or a trigger. SNS is another service by AWS which just sends notifications that, hey, something has been done. So this S3 bucket will send a notification to another service in AWS called Lambda. Lambda is basically, it's basically a code you have written, and it just executes when it is invoked or triggered, and you don't have to worry about maintaining any infrastructure to run that or execute that particular piece of code. So as soon as the drive hits there, we add in our BitLocker key as well, because across Amazon, Windows, Linux, Mac, everything is full disk encrypted. So we need to add the BitLocker key, and as soon as it is done, the Lambda will be kicked off, which will start an EC2 instance and transfer the data from the S3 bucket onto the analysis instance. Again, because everything is in AWS, the data transfer is very, very quick. In matter of 1 hour or less, we get the 250 GB drive copied across to the EC2 instance, and as soon as it is copied, we have the entire those accidental tourist bash scripts which kick off the analysis for timeline, registry, browsing history, and prefetch. And once all those data is done, all those artifacts are passed, they are copied into, they are compressed into zip and uploaded back to another S3 bucket from which you can download all this data offline and just review them for your triage. So again, this helped us to reduce the amount of time we spent to copy across data from a bucket or any other resource into an analysis instance. And also it helped us that for one drive, we kept one instance so that we didn't contaminate data or we didn't mix analysis data or things like that. And once all this thing is completed, people can just start another accidental tourist script which will back up everything. So for example, what accidental tourist did is that you said that, okay, I'm ready to close this case out. It will hash all the artifacts, everything, and it will upload everything back to another S3 bucket for long-term storage. So in that, we can store data relatively cheaply for up to a year easily. And we don't have to worry much about the higher cost and things like that. So again, there's some pains with this sort of accidental tourist software analysis. What we did, first of all, it supported only NTFS drives because Windows was the primary focus for us. At that point, a few years ago, Windows was the primary OS used on the laptops and the desktops. And the other thing is, like, over the years, we learned that Windows matured in terms of providing much more artifacts which give you forensic value. So we started to reach a point wherein registry, prefetch, and browsing was becoming limited. We wanted to do more, like how about parsing EVTX logs? How about looking through the recycle bin and making sense of what was deleted and things like that. So again, in the timeline what we created was from sleuthkit FLS. So all the other artifacts we parsed, they were not timeline like log2timeline would do. And yeah, another was like majority of the code was written in Bash, although like I would any day love to write long Bash one-liners rather than all those fancy languages, but still Bash has its own limitations. It's slow, and on this analysis, one of the major things we lacked specifically for e-discovery was the full keyword searches, like ability to index the entire drive and analyze on that. And more and more incidents started happening, or more and more people wanted to analyze certain things, so the cost started increasing. One of the leadership principles at Amazon we have is frugality. So as much as possible, we want to be frugal. We don't want instances to be running for 1 year where we don't need. So however, we had this thing like one disk, one EC2 instance, and we wanted to change that. We wanted to do much more effective, efficient way, but being frugal at the same time. So this was some of the main pain points we had. Now, this is present day. What we are doing present day. Present day, again, I can't really say that what we're doing now. This is something we have been doing for many years, and day 0.5 is mainly focused on live response. We have been doing for many years, and how we have evolved from simple tooling to endpoint-based things, and how we have built automation around it. So what is live response for us? It's very simply put like ability to acquire either raw artifacts or certain past artifacts. Some of the things which were mentioned by Mike on Velocity Raptor, those all things resonate with us. This is what we want to do. And I wish we had Velocity Raptor about 3-4 years ago. It would have solved a lot of problems for us. So how were the first steps we took towards live response? So as we spoke earlier, we were mainly doing, grabbing the drives and doing analysis for the full drives. So if we had a piece of malware which we were not sure about, getting the entire drive and just pulling one file and then not doing anything with it was no good return on investment, whether it is for the cost of spinning up resources or engineers spending that time on those sort of analysis hours and things like that. So to reduce the amount of time spent specifically on malware analysis and things like that, and to focus on malware PE files, particular tool was written called Golden Retriever with a UI, wherein people can just specify the hostname and the path, which the file they want, full path of the file they want to acquire, and that will be acquired. Now the files were, however, limited to only PE files because, again, at that point we were starting into live response, working with legal and all those things. We have to be a little bit cautious that we don't pull unnecessary personal data files. So this like PE files, it was limited to PE files, but it used SMB to grab that files. So this was a very simple service, but it brought down probably 10% of the full disk we were doing. Like it reduced the amount of full disk acquisitions we were doing. So what were some of the pains? Again, SMB, Windows support only, PE files, and we didn't have an API. Every time you wanted to go, you would have to go to the portal, pass in the path, and wait for it for the host to upload it back to your portal, and then download it from the portal and things like that. Of course, it did have things like compressed with password protected and things like that, but it was still a little bit some of the pains that we had with like no API and things like that. So we thought of going into a journey to see if we can find some endpoint agents and solve this sort of problems and they are across Windows and Linux and OS. And one of the things we wanted for our live response tooling for the response side of things is that we wanted minimum infrastructure. We did not want to have a lot of server and client things wherein because to support AWS to support Amazon corporate network, there are hundreds and thousands of hosts, hundreds and thousands of clients, and we would have to have a lot of different servers deployed across geography. Then we would have had to put CDNs and stuff like that to have it work reliably. So we wanted minimum infrastructure maintenance, and the other main capability we wanted was execute custom scripts, custom binaries. Like if you wanted to write a PowerShell on the fly, deploy in the host and do something with it, we should be able to do that. And very important, API support. Again, we don't want to go to UIs, many vendors do that, but we wanted API so that we could tie it to whatever workflow we wanted. And to scale things, to give you perspective of that, the ability, what we wanted is that if I wanted to pull, let's say an MFT file from 10,000 hosts which are online, I should be able to do that. And I should be able to upload them straight to S3 bucket. We don't want to do that on any of the FTP servers and things like that. Everything to go through S3 buckets. So I don't know if you guys can read that, but basically this was some of the detailed requirements which we put together. We just got some of the things are like we should be able to query the data, like just run query and grab the artifacts, get raw artifacts like registry hives, browsing history files, MFT tables and things like that. And we should be able to customize and run scripts, ability to have memory forensic. We should be able to get full memory dumps. Also, we had a requirement to get like we want to run recall or something like that on a particular process and not get the full dump. Similarly, data processing things and minimum architecture, authentication, and those are all the requirements. So we looked at a few of the open source products, commercial products, and things like that. At that point, there were many nice commercial products, but most of them, if you talk about endpoint agents, they were sort of going into the space of detection. And eventually, now it has become EDR, XDR, or any of those fancy names. But our problem was response. As I said, detection was not our focus at that point. Response was our focus, getting the artifacts and things. So we found one commercial endpoint solution. Unfortunately, I cannot name them right now. But through the talk, some of the things I'll mention, you might be able to guess them, who we are talking about. But they provide us like API, minimum server maintenance. Like we are maintaining right now our fleet of all these endpoint agents with really small number of servers, really small. Script execution, and the other thing was scheduled deployments. So for example, if the host is offline, you can deploy a particular package or an action saying that, hey, I want to grab this particular thing. When the host comes online after 24 hours, you will be able to get that data. But again, this was like really good find for us, good evaluation for us. I mentioned mostly about the commercial solutions. At that point, forensic focused solutions were very few. One was Google Rapid Response, which was really focused for response for forensic. However, at that point, GER was very much tied down to client-server architecture with having your servers rather than for us ability to change things around and deploy it on AWS, scale it with S3 or some other microservices architecture. That's why we did not really move forward with something like Google Rapid Response. So now we have this particular endpoint fleet and live response tooling deployed. It allows you to query and things like that. It allows you to deploy scripts and your binaries. So we wanted to have certain capabilities. One of it was that how about we grab the entire partition when the host is online through live response. So inspired from the good things about Polaroid like multipart and things like that, we wrote a tool in Golang, because Golang is much, much faster, which would acquire the entire partition or the disk, depending on the OS, and upload it to S3. Again, this Polaroid binary basically works across Windows, Linux, and Mac. And the benchmark we found initially was like a 250 GB drive was uploaded in 3 hours. So from 8-10 hours, we have reduced to 3 hours. It's a pretty big win. And another good thing or bad thing, depending on how you look at it, because we are doing from the live instance, they were all decrypted drives. So again, sometimes this is a difficult discussion because we are grabbing the decrypted drives and storing it somewhere. So there is a risk on that. But this has worked wonders for us, in the sense that at times we don't have a particular IT support or a subsidiary we have had, and we just deploy this thing and we grab the entire drive, entire partition or disk. So again, live response has certain limitations as well, and the Polaroid itself has certain limitations. So you are basically reliant on how is the internet connection and if the host is available. So you might have had like 200 GB worth of data uploaded, and suddenly the user closes the lid. You're lost. You can't do anything about that. So that is one of the pains. Although resume capability has been built into Polaroid, but because we are using live things like this, at times we don't have proper access to what sort of things have been uploaded so far. And that's why the resume capability is limited. And the way that particular endpoint agent works, the commercial endpoint agent, it deploys certain action and kicks off this particular process of Polaroid. So we have visibility into that a particular package was deployed and Polaroid has been executed. But if it has failed, if it has paused or run into some errors, we do not know that. So we had limited visibility on what was being uploaded. So moving forward, we were like, getting full drives like this has been useful, but we should do something very specific to pulling just a particular set of files. So we wrote something called file and retriever. Again, some of the good things from Golden Retriever by specifying path and things like that, but again, this was written in Golang. So in this, what happens is a user can specify a full path, and it was not limited to PE files. Any file you could provide, any file path, anything can get, and it will be uploaded to S3 bucket. And again, it worked with Windows, Linux, and Mac. So now we have the capability to getting the full image if you wanted, and we have the ability to get one particular file from the host, whether it is Mac, Linux, Windows, anything like that. So now this is the third artifact. So this is the third capability. This was mainly part of our the commercial endpoint solution we got, live response. So what this did is you specify configuration or collector files where you specify what you want. You bundle like, I want registry file, I want browsing history, I want MFT, and it will grab all of that things at once and upload it to an S3 bucket. Again, we like S3 buckets because of the flexibility, so you will see through the talk that everything goes into S3 bucket. So this is the example on how the collector configuration looked like. So you can see that it supports environment variables, it supports regex, and you can say how much do you want to recurse further down into a provided folder or something like that. So again, not only just a file, we can do files and folders entirely. And you can see here, the maximum number of files we want is 3. If anything more than that, we are not interested. So whenever the regex runs, if we select the first 3 files, it'll be done. So you can change this particular all the fields. And another good thing with this particular live response agent was that it supported API, and what we did is that we wrote a wrapper around that API. So it took care of all the deployment of golden retriever, file and retriever, or artifacts, and people didn't have to go through the portal, fill in the parameters. Most of the things were specified on the CLI. CLI will fill up, grab all the credentials required, and deploy on the host. Say that, hey, you have to go and upload this particular file via Goloroid or whatever, and it will be uploaded to S3. So again, going towards more automation with the live response toolset. So basically, how did we do live response analysis? So the artifacts, which were captured, the raw artifacts which were captured into S3 bucket, what did we do with them, and how did we analyze them? So basically, whatever is uploaded into S3, we would run AWS Lambda jobs. So as soon as, like earlier, what we saw in Polaroid is when a particular file hit the S3 bucket, there was something triggered which ran a particular code to do something. Similarly, this was the case. So for example, if a registry file hit there, the Lambda job will look at it and it will upload it, it will start the analysis. Again, the lessons we learned here were like using this live response flexibility to execute scripts. We have done some scripting to say that we want to disable this particular host. A PowerShell script is written, deployed, and we are done with it. And microservices architecture worked really, really well for us. When I say microservices architecture, it's like we're still using EC2 instances to do some analysis, but it's still like not using like small code, micro code, and things like that. And the pains, again, microservices are limited. For example, Lambda has limitation for running for 15 minutes only. If you have to do something very intensive, compute intensive, this Lambda thing would not work. You would have to go to something else. And again, we needed better means of tracking end-to-end. From acquisition to analysis, we wanted better things. And the other thing was, people started to say like, hey, we have too many tools. Which tool should we use when to acquire certain things? So this got us into day one. Day one is like what we are doing now, the actual forensic platform and things like that. So right now what we have is, ability to extract files to FileTan or artifacts, full disk through Goloroid and Polaroid, and for analysis we have external tools and AWS Lambdas which we have written. Before I go further into the corporate side of things like laptops and all the things, I want to talk about how do we analyze, we were planning to analyze EC2 snapshots. So this is a particular service called Kookaburra. This has been inspired from an already open source software from AWS, which is called EC2 Clean Room Forensic. So the idea here is that you have an API gateway, which is again another AWS service. You just pass JSON, which kicks off certain workflows using Lambdas, attaches your snapshot, and does the forensic analysis for that. And for forensic analysis, we are right now focused on doing log2timeline for Linux drives, ext4, ext3, XFS, and things like that, and extract certain artifacts. So do the log2timeline just to create certain timelines for file stat. And we want to extract certain configs because in Linux, everything is a file. Like you want to see what is etc host, what are the modules available, and things like that. And this service, we want to try and make it open source. We're not promising anything. We're working on this part where we should be able to make it open source in some time. So this is a diagram of the APIs. So you have basically right now 3 APIs listed here. One is Snap. So you pass in your incident ID, snapshot ID, and the region, and the analysis will start. So this uses step functions. So first it will create a ticket internally, then it will create an EC2 instance, mount the particular snapshot, create the volume from the snapshot and attach it, and this will start the forensic analysis. Now, the forensic analysis is basically using another AWS service called SSM. SSM is basically an agent which lives on your ARMY or your instance. I think from 2017 November onwards, pretty much all the ARMYs, whether Ubuntu, Amazon Linux, they all have SSM agent installed on it. It's just a matter on how you configure it and make it enabled. So it's like a live response agent already installed, baked into your ARMYs. So in that, we have configured certain steps again, where it'll run through log to timeline, psort, and a couple of things like that. And once that analysis is done, again, back to S3 bucket. So, and the second API here is the status. So as we go through the steps and what are happening, the steps in here and the steps in here, we have an API where a user or a particular automation tool can grab all that data, grab the status. In the status, you will have, like the region which is running in the incident ID, the forensic instance ID, which was spun up, and the automation execution ID, which is this one, which is here, automation execution ID. So this gives an ability to track the status and things like that. And this is the third API, which basically you can get whatever is uploaded into the S3 bucket, the artifacts which have been analyzed, you can request a pre-signed link, AWS S3 pre-signed link, which allows you to basically curl your details. So again, now we have Kookaburra added to the list as well. So now we have all those things working, whether it is EC2 analysis for your Kookaburra or all the different other tools for your live response. So we wanted one platform, which is Amazon Forensic Platform. So, and just one single API, which can do everything, as well as provide a self-service portal for, let's say, legal teams or certain other teams which are not very well versed with API calls or automation. And we wanted to support modular architecture, where tomorrow, if you wanted to update something else and add certain other analysis, you should be able to do that. And case management. So again, added end-to-end tracking, and all of this code will be written as CloudFormation templates. So if tomorrow we release this service, it will be a pretty much CloudFormation template. You can take it, put it in your AWS account, and all the resources will be spun up for you. And again, this we are trying to make this open source as well when we have further into our development. So initially, when we started planning this is particular the MockUp UI we wanted, where this was a self-service portal, wherein user can go in, specify the username, what sort of host they want to do, and what sort of artifacts they want to grab, and this is the main architecture for the forensic platform. So you have an API and a UI, which basically calls API gateway, and it will log certain things into the database. And if you see down in the pink blob, they are basically the workflows. So you can have all the step function workflows. So for example, a workflow to do registry analysis, a workflow to do MFT parsing, a workflow to do log to timeline. And we won't be limited to just Lambdas. We will be using ECS containers so that any compute heavy applications which are limited by Lambda can be run into containers. And again, the output will be in S3 buckets. So this is the contact information for our team. Basically, Carlos is located in Dublin. Hugo, Pedro, and Mary are located in Seattle, and I am in Sydney.
Thank you very much for your presentation showing us the evolution. Just to clarify, these are all your internal tools, right?
Yeah.
Okay, but are you like releasing some of them? Because I saw that it's Amazon confidential.
Yeah. Yeah. So again, like we are trying to release the tools as soon as we can. Being in Amazon, we have certain guidelines to follow. We have to go through certain legal, PR, and bunch of open source related things to be reviewed. As much as possible, we will try to release.
Hi, thank you for your talk. About 4 or 5 slides back, there was an acronym there, LAAS. I was just wondering what that was.
What was that?
Bingo.
Yeah, this is basically infrastructure as a service, or infrastructure as a service.
Oh,
Yeah.
IaaS.
Yeah.
Sorry, my bad. Cool. Thank you.
Just wanted to check if right now you guys have a capability to extract memory from the servers that running on, say, EC, for instance?
Yes, we sort of have, like the short answer, I can't give you more details about that, but yes, we sort of have the capability to get from Linux machines, which are in the cloud, in the AWS cloud.
What about Windows and Mac?
Yeah, we have. So Mac is basically not in the cloud.
Okay.
we can't run Mac on the Amazon AWS cloud. Yeah, with Windows and Mac, Windows and Linux, we have memory capabilities. But again, like what we have seen is that the Windows footprint for our services on the AWS cloud is very, very small.
Do you use your own tool or do you use the open source tools?
Open source wrapped into our workflow.
Okay,
Yeah.
fair enough. Thank you.
All right, thank you everyone.